Good morning, class. In today's module, atomic structure for class 9. Atomic structure is something that you've done in class 8 also. So once again, in class 9, we'll revise that atomic structure. Now this concept that atom is the smallest particle, that was given first by an Indian scientist, that is Maharshi Kannada, in the 6th century BC. And he said that Parmanu is the indestructible particle. Said that that's the smallest particle, but it does not have an independent existence and it is indestructible. It cannot be broken down. And but they have their individual specific properties, and Parmanus join up to give a bigger particle called Anu. So that was Maharshi Kannada's theory. Democritus gave the name atom to the smallest particle of matter, and then Dalton proposed a theory that we all know is the famous Dalton's atomic theory. Now this theory, he gave certain points that we have already done in the last class, that gave certain points that remained undisputed for a long time. Later on, the scientists proved that almost all the points of atomic theory given by Dalton was erroneous and incorrect, and only one point, that the atom is the smallest particle taking part in a chemical reaction, that is valid. Faraday was working with experiments and he showed that electricity is conducted due to charged particles, and Stoney gave the name of these charged particles as electrons. William Crooks was a scientist, English scientist, British scientist. While working, he found out that the gases does not conduct electricity. Gases, under normal circumstances, gases are poor conductors of electricity. He was working with this discharge tube experiment. This is the discharge tube experiment, that under normal circumstances, normal pressure, the gases do not conduct electricity. But if a high voltage, even if the high voltage is applied and the pressure remains normal, then also it does not conduct electricity. But he went on doing various experiments, and then what he found, that when this pressure was lowered to a very, very low value and a high voltage was applied, then the gas starts conducting electricity, and it starts conducting electricity in the form of rays. In the form of rays from the cathode towards the anode. And this, he found it out, but it was J.J. Thomson who studied the properties of these electrons. And so this was the tube he had taken. This is the discharge tube. This is a glass tube of 50 centimeters long, and there are the two ends are sealed. Here you can see both the ends are sealed. Now this is evacuated. A gas is taken inside, and this is connecting to a vacuum pump, and this is evacuated till the pressure inside is only 0.01 mm of mercury. Normal pressure is 760 millimeters of mercury, and this, what is the experimental pressure over here? 0.01 millimeters of mercury. There are two electrodes at the two ends. The one which is connected to the negative terminal is called the cathode, and the one which is connected to the positive terminal, this is called the anode. A very high voltage of 10,000 volts is applied over here, 10,000 volts, okay. And what is the pressure? Experimental pressure is this. It was seen that rays started flowing from the cathode towards the anode, and these rays, if a perforated anode is taken, then it passes through the anode and makes scintillation. This is the zinc sulfide scheme. This is the zinc sulfide or soda glass zinc sulfide screen. So scintillations were caused, or they started glowing with a green color, fluorescent light, when and what is the characteristics of ZNS screen is that when any charged particle hits the screen, then the fluorescence is caused. So he showed that when high voltage is applied to a very low pressure of a gas, any gas, then the cathode rays. These he called as cathode rays because they originated from the cathode and traveled towards the anode. He named it as cathode rays. And the cathode rays, if this is taken as a longitudinal bar, then it can be shifted to one side so that it produces, these rays can pass through and produce scintillations over here. Now what were the properties? I told you just that the J.J. Thomson was the one who predicted the properties, who found out the properties of this rays. He said they travel in straight lines. Because any object placed on their path, they created a shadow over here. So only when this light is, or whatever the rays is falling on straight line is perpendicular to the object, then only a shadow will fall on this. Then they produce fluorescence on the zinc sulfide screen. If this is shifted to one side, then we see that it is glowing with a green color, a fluorescence scheme. Zinc sulfide or soda ash also it is called. It can be taken. Then the third, it is affected by magnetic fields or electrical fields. Magnetic or electrical fields. For this, another, in the same experiment what he did, he placed two electrodes over here. One electrode over here and the other electrode over here. He connected this to the negative terminal and this to the positive terminal. It was seen that these rays, instead of going straight now, these rays got deflected towards the positive pole. They got deflected and they were repelled by the negative plate, negative electroplate. So that means what? These must contain negatively charged particles. That is why they are attracted towards the positive pole and are getting deflected from the, repelled from the negative pole. Then they are affected by electrical and magnetic field. They are made up of particles and possess kinetic energy. How was this proved? I am just rubbing out this again. In the path of these rays, he placed a paddle wheel. Paddle wheel is something like this. It looks like this. All of you must have seen a paddle wheel. Looks something like this. In front of your bike or a cycle, when you are riding a cycle, you hold it, it starts moving round and round. So when a paddle wheel was placed over here, very light paddle wheel was placed like this, it started rotating. So when would the paddle wheel rotate? If some bodily motion is there, if some particle is hitting it, then only it will make it rotate, isn't it? So that proved that they are made up of particles and they are moving. The particles are in motion, they possess kinetic energy. The particles are moving, that is why it hit the paddle wheel and it started rotating. Next is they ionize the gas through which they pass. The gas what is passed over here is taken over here. They ionize. These particles ionize the gas, means they rip off the electrons from the atoms, neutral atoms, and makes positive particles. They ionize the gas through which they pass. Next is X-rays are produced when they hit a metal plate. When they hit a heavy metal plate like say tungsten, it produces X-rays. The ratio of the charge, E is taken as the charge, means E by M. Charge to mass of the particles remains the same irrespective of the gas taken. Whatever gas you take over here and whatever material this electrode is made up of, these two metal plates are made up of, it does not, irrespective of that, the E by M ratio, that is the charge by mass ratio, remains the same for all gases. These were the properties of the cathode rays. Okay. And J.J. Thomson, what was his conclusion? It was his experiment. He only studied the properties and he concluded that cathode ray consists of negatively charged particles. He called them electrons. So negatively charged particles, that is why they were attracted towards the positive pole. Here where they are infected by magnetic and electric field, it was moving towards the positive pole. That means what? It is negatively charged particles. So electrons have a electrons consist of negatively charged particles. Next is electrons have definite E and M, definite charge and mass, irrespective of gas used. Whatever may be the gas used over here, their charge by mass ratio is always same. And thirdly, electrons are the fundamental particles and integral part of all atoms.